Good morning, everybody. I'm really pleased to be there. So it was a very complete introduction. So yes, I work for DNB as an education application support based in Paris. I had the chance to take care of DNB Audio Technique as a subsidiary in Paris with what we call the Soundscape Experience Center. So I have a studio with a soundscape system since the beginning of 2018. And also, I am part of the Audio Engineering Society since my student age 25 years ago, and now also treasurer of the French section. And this is correlated with the topics because I'm not there to talk about any brand, but about this multiple brand initiative we name ADM OSC. First, what's that? I hope it won't be too boring. I have no demo or things to make to you to listen today. But the question is, what is ADM OSC? It's an ID that rise 2019 something. To maybe it will be time to think about standards to ease the transfer between different kind of renderers and production with object-based audio. Maybe it was a little bit too late because there was also already a lot of application, products, software available on the market. So usually you can start with the standards before doing the products, but we already had some products. So the idea was, it's a little bit original. It's not really a standard in an industrial way, usual way, but we tried to figure out what was already there and how we can adapt a little things to be easy to do with the actual implementation and the actual solution, so we can really use it now and not wait for 10 years for a next standard and everybody implement it. So yeah, we recycle a little some old ideas like the ADM and the OSC. So it is mainly about object-based audio. We'll get maybe a little bit deeper why that. And the idea was at the beginning why link it to ADM. It was to unify workflow between the live and the studio and the broadcast. So yeah, really the context at the beginning was if we use already ADM is an already existing standard in the broadcast. So if we use in the live domain for the production the same kind of standards, maybe it will ease bridge between them. So for example, to do a live show that will be broadcast on TV or radio, or to use pre-produced contents made in studio in some live application or in some live venue and things like that. Good thing is we start a few in 2019. Maybe the discussion start with something like 10 people in the AES French section groups of discussion. And now I think in the emailing, because it starts with the lockdown and things like that, it starts as an emailing list and a lot of Teams meeting and Zoom meeting and things like that. And now I think there is something like 50 people around the table to participate to the debate with key developers and manufacturers. We see it in use in different kind of application like DAW, live engine, controllers, tracking system. And we saw a growing industry adoption on this idea. So maybe we should start, I can give you a few words because maybe you never heard about ADM. ADM is a standard. It doesn't come, you see I stole the picture from colleagues from the BBC R&D. The purpose of ADM is a common ground for audio metadata. It has been developed it is at the beginning a broadcast wave file format, so it's a storage format and something you can spread and distribute, but it's not real time. Important, it's a free and totally open standard. Everybody can use it. There is no license cost, no agreement, no certification, something like that. And it started as the ADM and the BBC R&D research. It was also a big topic for the EBU and a lot of stakeholders. And finally, it's also now a standard, a real one, approved by the ITU, which is the BS 2076. It has been approved as a standard in 2015. So it's more than 10 years ago. The goal was to ease the distribution and to be connect agnostic, very flexible and versatile, not too complex, simple, I don't know, not too complex to represent. And the goal was to ease the exchange of contents, so more contents, store contents. Avoid locking the producer in one vendor ecosystem. And we see it in use in a lot of, commercial products or solutions like MPH, DTS UHD, Dolby Atmos, AC4. They all use to describe the metadata, the ADM standard. It's also a future-proofing of content because it's quite agnostic to the technology. This is also a very good point. Also. What is SADM? SADM is a little bit newer than the ADM. After a few years, the EBU start to think about how can we stream the metadata. So we had a standard for storage, and now they are speaking about how can we transmit it alongside video flux or only for audio for radio. And this is how it gets to SADM, which is for serial ADM. So the idea is to put the metadata into frames rate to serial them, so you can transmit them in real time. And it has been approved also in some standards. You can use different kind of transport. There is already existing standard like the ST337 and others, depending of the transport layer, AES3, MEDI, or the IP for the latest 2110. Maybe it's not finished. We can imagine, of course, other things. So we may have gone to, you may ask, why don't you do another standard with the ADM over OSC? That could be an idea. The feature of this was to, this is important, is what they expect and what they are doing with the ADM and the SDM right now. For the broadcast, it is interesting, of course, for immersive audio, you guess it, but for other things, typically the dialogue enhancement, changing the dynamic depending of the noise, the context of the broadcast, multi-language. This is very simple object, but you can have several objects. One is speaking French, one is speaking German, and one is speaking English. And the user can switch and hear the mix and change the vocal. Audio description support, commentary or dialogue section and adjustment. Audio object movement. Now we get into the interesting stuff of having audio objects. And also headphones virtualization. It is quite limited, we can say from now. It's not a full set of descriptors of what we hear or the describe, for example, the room effects or describe more deeper what we can hear. Maybe it's the future of that. It has been made also with the actual needs and the most useful features for the broadcast first, and maybe think about other features in the future. The reason for that, it's back. No, this one is off. Okay, thanks. So this one has a higher gain. Yes, just a few features. One of the reasons of that is you have to consider that from now, I remember at the AES show in October, I saw a conference from Dolby explaining what is the sound of the future about immersive sound, and they still think about object-based audio for them is still the future, because the main reason is the bandwidth limited of the broadcast, because a lot of broadcast situations are only bi-channel, stereo, let's say. So for radio, for example, they use a lot the binaural renderers and rendering because it's only 2 channel, because it's the limitation come from the broadcast channel bandwidth. They can just transmit 2 channel. In the TV situation, they have a little bit more, but not so much. At the beginning, everything has been dimensioned 20 years ago for 8 channel. Now they can find some way to reduce the bit rate, and by using not linear compression and things like that, they can rise to 10 channel or something, but it's the maximum. So it's from now, because of the limitation of the broadcast pipe, which are available, mainly it's still because, for example, if you have 5.1 and it's already 6 channel, and if you can do 4 language, you already reach the 10 channel limit of object-based audio. So of course it's not huge, and quite often they still use the headphone, and the most in-use technology is the headphones. Why OSC? As I told you, we instead of saying, oh, we build a new standard, which use a new layer, we think it will be great to use something which was already implemented in a lot of tool we have. So OSC is there. So this is why we say, why not trying to convey maybe not the full set of ADM, everything, but the most interesting part, the things which are constantly dynamic things, I mean, which are changing during a show by over OSC. OSC is why I think everybody maybe know about OSC, but if you don't, it's an open protocol also. It's documented. You can check under the opensoundcontrol.org website to have the specification. It's very lightweight network protocol. It's quite easy to implement, even in microcontrollers, embedded headphones or hardware controllers for musicians and things like that. So it's easy to program. It's human readable. Not so difficult, better than the MIDI SizeX or things like that. And it's available in a lot of platforms. Who use it? This is a few examples. We can find OSC in DAW, digital audio console, gaming engine, object-based editors or renderers, in show control also, tracking system, which are automatic tracking system. Show control is a piece of software which is made to not linear like a DAW, but it's kind of DAW, but you can interact during the show. And also video system, even if the S in OSC for sound at the beginning, we see it in use in a lot of other systems like video and lighting also. So it's quite available, and maybe it's the easiest common point on a show between all the equipment, even not only for sound, but also for light and video. The general principle of OSC, first it's unidirectional. It can use different kind of protocol in real, TCP, IP, and UDP, but we focus on the UDP one, and it sends, you have just one sender who sends some metadata to one receiver, so it's a one-way protocol. The sender is usually, in our case, an object editor, or it can be a DAW to playback or a controller. It sends positioning data to one or more receiver, and the receiver could be a DAW if you want to record the object-based production. Can be an ADM renderer if you want to listen to it. It can be an object editor, or it can be bridge, typically a bridge to serial ADM to broadcast it for TV or radio broadcast. To ease things, one key of under the idea of the ADM OSC is to normalize everything. So everything is between 0 and 1. So it's agnostic to any space. So it means that usually it's the receiver will need to define some scaling to adapt it to the context of the reproduction of the broadcast. This is an example. I stole this from the BBC R&D again, and this is one of the first the first, let's say, real-life trial that was made with the BBC and the L Acoustics. You see the ADM OSC is here in the middle. It was just a part of the whole show. It was made for the Eurovision. I think 2000, oh, I missed the date, 2021 or 20? I don't remember, something like that. So you see, ADM OSC was just to ease the communication between the ELISA controller, for example, and the processor, which was used in the venue, and the binaural production tool to broadcast some binaural. Here you see you have the OSC to ACE ADM generator and squeezer. What is the squeezer? The squeezer, the role is to figure out how we can reduce the number of channel count to the bandwidth limited at the end, which was in this case 15 channel, you see here. So yeah, we need to develop the BBC R&D developed this squeezer as a custom-made solution for that. Next, it goes to SDI encoders, and you see for the broadcast. Yeah, this is typically an example of use case and one of the historical, let's say, the first one that use ADM OSC. Last time I saw the colleagues from James Cowdery from Dolby show me this picture, which is a little bit newer. You see, this is another example coming from Dolby documentation. You have the performance audio, the front half house, audio and ADM OSC sent to the broadcast mixer, and you can find it again here, sending to the contribution encoder and gateway, which mix it up with the video flux and broadcasting this. Next here, and on the opposite side you can find another live ingester which will reproduce audio and ACADM, etc. So this is another example of the kind of signal flow, let's say. A little bit story. So we had a chance to organize after this lockdown area and a lot of discussion. We thought it will be great to meet in person. So in 2023, I had a chance with the help of the AES section to organize at Radio France the first Plug Fest. It was the first time to meet in person and try to figure out what is working. Oh, this is Dave from the BBC. And you see there was a lot of players, all the people who were discussing came to this room, and it was occasion to do some real life testing and see what is working, what is not working. We find a lot of new issue and solutions even during those 2 days of work. It was very interesting, and one of the first way to see, hey, not everything is working, but a lot of things are already working. It was great to see. Next big step was in October 2024. We had a chance to present this initiative to the AES officially at the New York show. It was also the occasion to do a paper, so it was also the first publication of the specification. ADM, we name it ADM OSC 1.0. Which was published in the AES library. It's an open access, so you can download it for free. It's not extensive. You see all the comments are there. So everything, of course, is public and open, and everybody can use it. So you see the idea was just to figure out, can we agree about a set of common commands, also kind of types, normalize the ranges, so it's easier to bridge between different kind of technology. And also in the paper you will find also additional information like convention of the axis, where is the forward axis, rotation, so you don't need to do some complex trigonometric change. If you need to switch from Cartesian to polar also, we introduce the same kind of normalization in the equation that use ADM, so it also is. It's not very complex technically, but it is just to say, we have something published, everybody can use it, so if everybody do it, it will ease the interoperability. You see that there is already there is some how do you name it, in the namespace, like the ADM/object, which relate to sound object descriptors. We introduce the first thing with the environment thing. It's very simple. It's just a change message. So it's just to say something has changed. It's quite open. You can do what you want with that. It can be oh, we changed. It's a new song, or it's a new scene in a theater project, or it's day or night, or anything. In fact, but yeah, it's just a way to say that. Maybe at the end it will just trigger like a program change in the reverb or something like that. It's up to the renderer, to the receiver to decide what he will do with that. But we can transmit that also. And also we introduce some listener descriptors, which is interesting, even if it's not really in the ADM. From now there is no listener interactivity included. So it's by default, they consider that the listener is always, direction is always looking to the front direction, so there is a front direction, which is, it comes from the screen, of course. At the beginning there was a screen, but now we start to introduce that, because even if it's not in the ADM, we thought it could be very interesting for virtualization of our headphones to have some common descriptor also for the listener position and the head orientation. So we introduced that also, and keeping the same recommendation for use with the convention of the direction, you know, your pitch, roll, and things like that. So everybody used the same kind of descriptors for this. It was also the occasion to do a second Plugfest in New York. It was organized with the help of Agnieszka at the NYU. I was there to demonstrate grapes, really. You see on the left, which was one of the software which can send ADM OSC to everybody in the room. There was a lot of stakeholders. You can see DS100 from the NBA, but Galileo from Meyer Sound also, and other stuff. What about this is a picture, it is also in the AES paper. It is where now we see the ADM OSC in use, because at the beginning, the first goal, as I show you in the BBC R&D picture, was to just bridge the live to broadcast. So we can say that at the beginning, the idea was just this feed to the ADM squeezer, and they think, oh, this is interesting already to have ADM OSC to do that. But here on the picture, everything is ADM OSC. In fact, could be, or maybe. You see, now we see also that not only helping switching from live to broadcast, it also help for different kind of devices or software to discuss together. So it's also a way to have some object and images software. For example, the Grapes 3D will come in this category, which can send it to different kind of renderer, but also hardware controllers, also real-time tracking system. For example, Dolby in New York was very interested to see how we can use the live system you have for real-time tracking of the people. Maybe we can use it also in broadcast. It helps also for them to use this metadata. Console surround panel also. You may want to have a controller which is on the console, and maybe instead of having 12 surround panel for every brand, it could be good to have one single standard surround controller that can talk to everybody. Show controllers. Metadata controller or bridge, we can just do bridge, and you know, we found that the SADM quizzer and the time deferred. This is the broadcast part with archiving also. ADM broadcast web file is very useful for that, with recorder and player, and digital audio workstation also on this side. Maybe VR and augmented reality, game engine, interactivity things, head tracker, and of course on this side all the broadcast way, so maybe headphones, home cinema, TV, the new immersive sound system that will maybe receive directly the ADM OSC commands, and the monitoring speaker or headphones for the production context. So now we see that it's much wider than what we think at the beginning. This is about the implementation matrix. It was also, this is something we start with the Plugfest, because one rule we agree in the group is everybody doesn't have to implement all the commands and all the features. Of course, some are maybe more relevant for some stakeholders and some are not, and it's totally okay. You don't have to be 100% of the implementation to be already useful. For example, for a controller, it doesn't make sense to receive ADM OSC. It can be just a sender, or a renderer can be just a receiver. It doesn't have to be bidirectional. For some thing, it could be useful to be bidirectional, but not for all. So this is why we think it could be good to have a kind of common place to find the documentation. Maybe it's time for me to do a short stop in the presentation and show you how it looks. So this is, I will give you the, don't worry, I will give you a QR code so you can find back the link. Everything is open source and contributive, so it's based on, we use GitHub to build this open standard. You see that on the GitHub you have some issue. The GitHub issue is the kind of discussion forum, so you can jump into the issue and see what are the, oh, it's not working. Still connect to Wi-Fi? Maybe not. Let's try again. No issues. Everything works. So you see the issue, for example, now we have 22 open issue, and it's just places to discuss about IDs. You can contribute, you can jump in, and you can say, oh, I have this idea, I think it will be great to have this. And we discuss about, okay, can we understand exactly what you want to do? Is there some challenge for others to do this? And yeah, it's just really open discussion about different kind of things. You know, Lucas Dwicker, for example, for Labo is really active also on the groups. And speaking about effects ends, we start to discuss about how can we describe the room effects and things like that, which is very big topic and passionate one. But you see, so this is how it works. You can discuss and participate to the exchange if you want. Everybody is welcome. And there is also a GitHub EO page, which is the living standard documentation. So here you can find, and it's updated, of course, real time. So you see it's, 10 of June is the latest update. If we see, for example, on the list now, this is all the players who already express some interest to implement it. So you see that the list is quite rising. Now we have a lot of people there, which is good. It means that it will really be something useful, I guess. And of course you can come back to this. You have all the descriptors, and yeah, I was talking about the table. The table is there. So you see now it starts also to maybe we should think about a new way to represent it. But yeah, you see everything is on the GitHub. As I am here, let me check that time. Oh, not so much. Yeah, you will let me know. If you want to know more about EBU, I will. You have also the same kind of things. ADM.abu.io if you want to see what is the ADM, different kind of audio which is behind, because you have channel base, scene base. In the ADM you can have object base and matrix base, binaural base. It's quite open to a different kind of rendering. As I told you, why the broadcast is now using more channel-based or binaural-based is because of the bandwidth limited. On the opposite, us in the live domain, we are mainly using object-based because we have no issue with bandwidth. Actually, we can have 500 of channels. It's very easy. We have our local area network, so we have no such constraint that they have. So this is why we use much more the object-based audio. So if I go back to this, because I want to give you yeah, this is a little bit example use case. Sorry, I recycled some picture from the AES show presentation. This is the one from Luca, speaker from Lavo. He just gave an example of when they use the ZAC tracking system and QLab with ADM OSC to control their mixing desk, for example. And on the opposite, the mixing desk was sending back ADM OSC to audio renderer and DAW on the other side. I will give you a little bit more about this story because I was involved into this project. This project was start in 2021, so it was really the beginning. At that stage, the ADM OSC was not so stable, so it was really one of the first use case historically for me. So the idea was I was not so much involved, but I know very well the guys. They started the production in a studio which is called Dessin Animé, which is a little bit like here in near Paris, yeah. And they use for that the contents creation was made with Spat Revolution for binaural, and they use a Sonic Emotion Waves one with APG speakers, for example, in this room. And there was a first show next for Paris Nuit Blanche with binaural audio streaming made by Spat Revolution, and they used an adapter Fletcher machine prototype at that time, 2021, with Nexo speaker for this show. And at the end, Bertrand Dombrance came to the US to play in the Cube, which is a DNB soundscape stage on the festival. So this is the picture of the first show in Paris. What was interesting is in Paris, Dombrance as his sound engineer. So we spent a day, this is my room in Paris, we spent a day together in Paris to just double check if everything switched well from the ADM OSC to the DS100 DNB renderer. And next he traveled to the US alone, meaning with no technician. So everything was into this Ableton Live computer, and the challenge was it has to be easy enough, so just a musician can come alone and play the object-based audio on the show. So this is the picture of the Pétanville Format Festival Cube in September, which is a big acoustic space, immersive space on the festival. Just to conclude about future consideration, it's just the beginning maybe of the story. We think about other kind of things like joining it to EBU, start the discussion maybe about the listener position and all those things with the EB back to the EBU, especially about talking about VR and gaming engine, which are maybe a little bit more advanced also than us, and broadcast about 6 degrees of freedom and listener interactivity. Adoption to more and more players, of course, and alignment with other industry initiative. It doesn't mean that maybe in 10 years we won't use OSC, but other protocol. But I guess all the work made on the descriptors and what is useful, and a lot of things will be recycled even with new technology. So it's still worth to do. This is the QR code if you want to find the link for GitHub. And yeah, time for Q&A if you have some.